Hello students, hope you all are well. From previous knowledge, you already know that the physical quantities are two types. One is scalar quantities, another is vector quantities. So the physical quantities which have only magnitude and no direction are called scalar quantities. Only magnitude and no direction are called scalar quantities. Example: mass, time, speed, etc. And what are vector quantities? The physical quantities which have both magnitude and direction are called vector quantities. Example: displacement, velocity, force, etc. Now, the vector can be classified into two categories. One is polar vector, another one is axial vector. So the polar vector have a starting point of application. That means polar vector have a starting point of application. That means, suppose a body placed here, you apply a force in this direction at this point. Now the body moves towards this direction. So the force have starting point of application. So the force is a polar vector. The force is a polar vector. Suppose a body placed here and you apply a force at this point in this direction. Now the body moves here. So the body displaces here to here, there. So the S is the displacement of the body. So the displacement have also the starting point of application. So the displacement is a polar vector. So the polar vector is a vector that represents a quantity having both magnitude and a definite direction in space. It acts along a straight line. So force is a polar vector, velocity, displacement, linear momentum, etc. are also the example of polar vector. Let's talk about the axial vectors. Basically, an axial vector represents a rotational effect. It is associated with rotation. That means, suppose you give the rotation like this, then the axial vector acts along the axis of rotation. So this is the direction of rotation, and this represent the axis of rotation. So the axial vector acts along the axis of rotation, not along the direction of rotation. It acts along the axis of rotation which is perpendicular to the plane of rotation. So the example of axial vectors are torque, angular velocity, angular momentum, etc. Suppose I take an example of torque. Tau is equal to R cross F. Here tau represents the torque, R represents the position vector, F represents the applied force, so here position vector R and applied force F are the two polar vectors. So basically the cross product of two polar vectors gives the axial vector torque. Torque is an axial vector. So now talk about the direction of axial vector. This is the plane of rotation. So here the R vector like in this direction and F vector in this direction. You give the rotation anticlockwise, then the direction of rotation then the axis of rotation in upward direction. So it represents tau. And if you draw a plane of rotation and you give the rotation clockwise direction, then the axis of rotation are in downward direction.